I'm Alicia, and today I'm going to introduce touchless technology, then demonstrate how easy it is to specify and use a touchless angle sensor. Touchless angle sensors detect the field orientation of a magnet as it turns on your application's rotating part. This provides the angular position. There are basically two parts: the sensor with its electronics enclosed in a housing and a matching magnet. This touchless sensor magnet pair is Novotechnik's RFD 4000. A variety of magnets are available for various application situations and mounting requirements. The distance range is defined by the strength of the individual magnet used. In general, bigger is better for better linearity in spite of radial misalignment. The trade-offs are that bigger magnets are more expensive and occupy more space. A larger size of magnet also allows for greater distance between sensor and magnet, and with a stronger magnet, the axial tolerance range increases as well. Magnet strength limits the usable distance range and permissible radial misalignment. Hall effect sensor chips need to be mounted on axis with the rotating drive shaft of the machine. There are centering features included in the housings that should be used as references to features on the mounting surface. These include the round circumference of the housing itself, locating pinholes, or somewhat less precise, the mounting screw holes. Most touchless angle sensors can be mounted on the top or bottom of their housing surfaces, allowing for measurements through non-magnetic walls, mounting the sensor on the front, on a plate, or a specially dimensioned hole in a mounting plate. Let's take a look at the touchless angle sensor in action. We have a digital display that also powers the sensor, and the RFD 4000 sensor mounted on the rear sheet of plexiglass. On the middle sheet of plexi is a magnet mounted to a rod with a knob. By aligning the reference of the knob at 12 o'clock, we get a reading of 0 on the display. As I turn the shaft clockwise to roughly 3 o'clock, we see the display change to 90 degrees. As the rod continues to turn, we see 180 degrees at 6 o'clock. And finally, at 9 o'clock, we see that the RFD 4000 has correctly tracked the rod's position through the plexiglass via the magnet to show 270 degrees on the display. Oh, and one more thing. It also works through non-magnetic material. Thank you for watching today. And for more information on applying touchless angle sensors, view the technical sensor tip article in the spring 2017 issue of Novotechnik's Mechatronic Sense newsletter. It's available at novotechnik.com.